Hi, my name is AUDRYLYIA, and I will be explaining about the implementations of HTTP. So the topology contains one server and one client and two routers. So basically, client is likely a device that wants to access information from the server, while server is a device that stores information and share it with other devices on the network like clients. And then routers. They are devices that direct traffic on the network that help send information from client to server and vice versa. So for the configurations for client 1, there is a ping box which is contain local address, subnet mask and gateway. So that is the configurations for the client 1. This is the configurations for R1 which is router 1. To check whether the configuration is successful, you can run the display IP interface brief and display IP routing table commands. Same goes to configurations for R2. And also if you want to check the configuration is successful, also same way. And then for the configurations for server 1, you can click the server devices to configure. And you can see like the local address, subnet mask, and the gateway. Perform a ping test on the client, enter the IP address of the server and click send. If the sending result is successful, the client and server can communicate with each other. Enable the FTP service on the server. Use a local folder and place a txt file, which is here. I use my document.txt in the folder for testing. So, use FTP to log into the server from the client to download the FTP file from the server. Step 1, enter remote address, and then step 2, enter the username and password. And then click the login, and then you will see the my document.txt at the remote file. After the preceding operations are complete, you can also view the process of the FTP server on the client through the logs. Enable the HTTP service on the server. Use a folder and place a txt file, which is my document.txt, in the folder for testing. So here you can see port is 80. Then access the server address through HTTP on the client and download the HTTP file from the server. Capture and analyze HTTP traffic using Wireshark. Packet 4 and Packet 5, the packets are part of the HTTP GET request and the corresponding HTTP response. Packet 4, source 192.198.1.12, the client making the request. So the destination 192.198.2.1, the server responding to the request. This is a GET request. The client is requesting that data from the server. And then for packet 5, source 192.168.2.1, the server responding. Destination 192.168.1.12, the client. HTTP/1.1 OK, the server respond, indicating success.
My name is Afiqah, and I'll be presenting about DNS, which is Domain Name System. For this topology that I make, in this setup, this PC is connected to switch, which is also connected to two servers, which is server 1 and server 2. Server 1 is configured as DNS server to resolve domains name into IP addresses, while server 2 is configured as a web server. The PC is set to use the DNS server for resolving domain names, allowing it to access the web server by its domain name through the switch, which facilitates communication. Moving on for the basic configurations. So for the first one here is server 1. Local address will be 192.168.1.2. The gateway for 3 of server 1, server 2, server PC2 will be 192.168.1.1, and DNS will be the same, 888. For server 2, the local address will be 192.168.1.3. For PC, IP address will be 192.168.1.2. So according for these addresses, when the signal will be sent, the messages will be command. It will be sent accordingly through the IP address. For this hierarchy, at the top is root level, which is represented by a dot, managed by critical root servers. Next are top level domains, which is TLD, such as .com, .org, .net, and .edu. And then after that, under TLD are second level domains, for instance, example.com. Another instance is google.com, like that, which can be registered by individuals or organizations. Further division within second level domains are subdomains, such as mail.example.com or www.example.com. Is used to organize different sections or services of a website. Next is the DNS records for configuration under DNS types. So we have 4 types, which is a record, which maps a domain to an IP for v4 addresses, and then right beside it is a record, which maps a domain to an IPv6 addresses. CNAME record, which maps a domain to another domain. I set type CNAME example.com, and there is the rest of the results. And for the last one is set type equals to fx example.com. It specifies mails that serve the domain.
Hello, my name is IZZATIE binti Muhammad Asri. Now I will explain about my topology, which is for Telnet and SSH. So firstly, let's discuss about the PC and switch configuration. So each of my PC is connected to its respective switch via Ethernet interface. For example, like PC1 is connected to switch LSW1 through the Ethernet 001 interface. And PC2 is same like PC1. It is also connected to LSW1, and PC3 is connected to LSW2. So for the IP address assignment, each PC is assigned with a unique IP address within their designated subnet to ensure the proper communication. So for example, PC1 has an IP address of 192.168.0.10, and PC2 has 192.168.0.20, and PC3 also has 192.168.1.10. So this configuration allow the PC to communicate within their subnet and through their network via their respective switch. To set up the configured gigabyte internet on R1, first thing I will enter the system view, and then I set the router name to R1, and then I access the interface configuration mode, which is I need to type the interface gigabyte internet 002. And then I set the IP address and subnet mask, and then I undo shutdown to enable the interface. So this is my configure interface gigabyte internet on ISP, which I do the same as the R1. I enter the system mute and set up the name as ISP, and then set up the IP address. So this is how I instructed the ENSP simulation environment to enforce the AAA. I will open the system view and open the AAA, and I will add the user by write the local user ICA privilege level 3 and type the password, and then I will set the local user service to type telnet, and then create, and then I open the authentication mode AAA to write the protocol inbound telnet. To test the connectivity, I open the PC2, and then I ping the 192.168.0.1, and then it will tell me 5 packet transmitted and 5 packet received. To connect the telnet session, I will open the command in PC2 and write the telnet 189.201.165.2, and then I need to log in authentication. So I put my username, which is ICA, and the password, and then it will connect. This is my data capturing via Wireshark. As you can see, it already captured the telnet in the Wireshark after you connect in the command PC2. For the SSH, I use the same topology using ENSP, and I do the basic configuration setup for PC3, which I put the IP address, subnet mask, and the gateway. On the same ISP, I set up the new local user for SSH, and then the service type will change to SSH, and then I will type the protocol inbound SSH and enable the Telnet server. I also do the configure interface gigabyte on ISP and the R3. So for ISP, I use the gigabyte 002 with IP address 189.165.0.16 and in port 3. And for R3, I use GB002 and also 001. And I set up the IP address. To connect to the server, I open the PC tray and I touch Telnet with my IP address, and then I need to put the username, which is IKA, to get the public key. This is my data capturing via Wireshark. As you can see, it's already captured the SSH using the public key that we have.
Hi, my name is AMIR DANISH, and I will be presenting FTP protocol. Starting off the implementation with the topology. I'm using 2 routers and 1 copper cable to connect both routers. The first router will be the FTP client, while the other router will serve as FTP server. The next step is environment preparation. I rename both routers to R1 and R2, and then I specify the IP address for the first router, which is 10.0.12.1, and the server IP address is 10.0.12.2. Next, I enable the FTP server and set the default FTP directory. Then, I configure a new local user on R2 by giving the username Huawei and set the password to Huawei123. The next step, I establish FTP client connection on R1. I type in FTP, following by the IP address of the server, which is 10.0.12.2. I also fill in the username and the password to log in as a user. I also use dir command to check the directory. I use the get command to add or download a new file. To make sure the file has been added to the directory, I use the dir command again to check the existence of the file. I also use the put command to upload the file. I establish the FTP connection again using the same way as before to upload the file to the server. As you can see, there are several login attempts and file transfer between client and server. Commands such as retr and stor handle file retrieval and storage, while commands like user, pass, and port are used to establish and authenticate connection. The exchange of data validates the server's answer to every request, indicating the completion of file transfer and command execution.
Hi, my name is ERWAN from IT, and now I will explain about the TFTP protocol. As you can see, here is the topology, which we have 1 router and 1 cloud for the implementation of TFTP protocol. So first, we need to configure both devices, which is the router and the cloud. So here is the configuration of router, where we need to set the name, which is R1, the port, which is we use GE port 000, and we put the IP address. So next, we need to configure the cloud. So here, we need to first put 2 ports, which is the first one is for the Ethernet, and the second one is for the UDP. So this is the configuration of the cloud to make this cloud as a server side for the TFTP implementation. So next, after we configure both devices, we need to look at the directory and to make sure that to look at the file that we want to send or we want to receive. And the next part is we will add new file using save method or function using the command prompt inside the router. So now, after the file is already saved in the directory, we can upload the file to the server through using the command, which is first we need to put the TFTP protocol, and then we need to put the IP address of the server, which is 192.168.10.100, and we using put, and we put the file name inside the command. And after that, the file is already uploaded, and then we can look either the file is uploaded or not using the directory. If we command using the directory command, we can see the new file is already added to the server. And then, last but not least, for the analysis, we can use Wireshark and we can see we can capture the process using Wireshark from the topology, and we can see the packet is transferred using TFTP protocol from the client side to the server side and the server side to the client side. That's all from me. Thank you.
To setting up a DHCP server in ENSP, this is my topology. Router R1 assign IP addresses DHCP server. Switch LAN SW has two VLAN, VLAN 10, 192.168.10.0/24, meanwhile VLAN 20 is the same as the VLAN 10, but change the 10 to 20. PC1 until PC4 get IP address from the router. Connection that I use is the router R1 connected to switch. Switch LAN SW PC1 and PC2 on VLAN 10, PC3 and PC4 on VLAN 20. This setup allows the router to assign IP address to PC automatically. For switch LAN SW, to begin we need to create VLANs on the switch. Firstly, create VLANs. I use command VLAN batch 1020 to create two VLANs on the switch. VLAN 10 for one subnet and VLAN 20 for another. Next, we will assign specific ports to these VLANs. For configure port VLAN 10, I use this command to set ports GE0/0/1 and GE0/0/2 as access port for VLAN 10. Access port connect IM devices to the switch, ensuring they are part of VLAN 10. Next, configure port for VLAN 20. Use command same as VLAN 10, but change to 0/0/3, 2 and 0/0/4. This is to set ports as access port for VLAN 20. Then, configure a trunk port that allows traffic for both VLANs. I use this command to configure port GE0/0/24 as a trunk port, allowing it to carry traffic for both VLAN 10 and VLAN 20. Trunk port to connect switches or other network devices, facilitating communication between VLANs. Finally, save the configuration. I use command save to save the current switch configuration to ensure that all changes are retained after a reboot. For router R1 byte, next, we need to configure the router to handle the DHCP assignment for the VLANs. Firstly, sub-interface for VLAN 10. I use this command to create a sub-interface for VLAN 10 with the IP address 192.168.10.1. This allows the router to communicate with devices on VLAN 10. Second, sub-interface for VLAN 20. I use this command to create a sub-interface for VLAN 20 with the IP address 192.168.20.1. This allows the router to communicate with devices on VLAN 20. Next, we need to enable the DHCP on the router using the DHCP enable command. This will enable the DHCP functionality on the router. Then, configure the DHCP for sub-interface. I use this command to configure the DHCP selection for each sub-interface. This ensures that the router can assign IP addresses to devices on each VLAN. To create the DHCP pools, I use this command to create the DHCP pools for VLAN 10 and VLAN 20. This configures the IP address range and default gateways for each VLAN. Finally, ensure all configurations are saved using save command to save the current router configuration to ensure all changes are retained after a reboot. For analyzing the DHCP traffic pipe, to verify the DHCP setup, check the IP configuration on the PCs and capture the DHCP traffic. Check IP on PCs. Use command ipconfig. Make sure to run this command on each PC to check the IP configuration and ensure they receive IP addresses via the DHCP. To capture the DHCP traffic, use Wireshark to capture and analyze the DHCP traffic. This is to verify the DHCP discover, offer, request, and acknowledgement packets to ensure proper DHCP functioning.